Okay, in this example, we're going to be solving a system of equations. This system is a quadratic and a linear equation combined. Now, as we solve the systems, we're going to be using substitution method. And the first step in substitution method is to make sure you have an equation with the variable by itself. In this case, both equations have a variable by itself. So I'm just going to put this first one in a box and just label it as my first step. Now the second step is to go to the other equation and replace that same variable that was by itself in the first one with the other side of the equation. So we're going to be replacing y with x squared minus 5x plus 12 in that second equation. The rest of the equation will carry down, so the 4x minus 8 will carry down. Now, since currently this is a quadratic, I'm going to follow the general process for solving quadratics. I have both x squared and x, so I'm going to move everything to one side. So I will subtract 4x from both sides, and I will add 8 to both sides. Give me x squared minus 9x plus 20 equal to 0. From here, there's a few things I can do since I still have both x squared and x. The ways I usually go about doing it is either by factoring, if that's possible, or quadratic formula if factoring is not. So I'm going to try to factor here, multiplying first and last since there's no common monomial. Give me 20x squared. The ways I can multiply to be 20, but add up to be 9, I think I'm looking for 4 and 5. With both of them being negative. Since there is no leading coefficient, I can use the shortcut, so I will end up with x minus 4 as one of my factors, and x minus 5 as another factor. According to the zero product property now, since I have two factors multiplied together to equal 0, then we just take each factor and sum individually equal to 0 and solve those equations. So I will add 4 to both sides for the first one, give me x equals 4, and I will add 5 to both sides for the second one, give me x equals 5. Now, since this is a system, we're not quite done. We need to go back and find our y values, because remember our answers are going to be something, comma, something, and something, comma, something. Right now we just have the x values of 4 and 5, so we need the y values that go with it. So we need to go back to one of our equations and plug x in. Now normally I would go back to the one that I put in the box, but that's quadratic and is usually a little bit more work. So I'm going to go back to the linear one, which is my second one, and I will replace my x in that one so that I can find y. So I'll replace it for the 4 first, so y equals 4 times 4 minus 8. 4 times 4 is 16, and 16 minus 8 is 8. So my y value with the 4 is going to be 8. And then I'm going to do the same thing with my value of 5. So y equals 4 times 5 minus 8. 4 times 5 is 20, and 20 minus 8 is 12. So when I plug in 5, I get 12 out. So there are my two solutions. In this example, we're supposed to solve the system of equations. We have x minus y equals 7, and x squared minus y equals 7. So we're going to be using substitution still in this example. So in order to do substitution, I need one of the equations to have a variable by itself. Now for this one, since x here in this first equation is positive, normally if it was a linear system, I would go for that one, trying to get x by itself in that one. However, that means I would be plugging it into x squared, and that gets a little bit more work than what's really necessary. So instead, I'm going to solve one of the equations for y, and I think I'll just work with the linear one here. So I'm going to solve the linear one, the first one, with for y. So in order to do that, I will go ahead and subtract x from both sides. 7 minus x is really just, well, 7 minus x. And then to finish getting y by itself, I will divide all my terms by -1, meaning y will be equal to -7 plus x. So that's my first step there. I'm going to have to come back to that later. I'm going to cross that equation out so I don't accidentally use it again. But now I will go to the other equation and replace y with what we found y to be. We found y to be -7 plus x, so I'm going to be replacing it with -7 plus x. So x squared minus, making sure I use parentheses because of the minus sign in front of the y, -7 plus x equals 7. Now we just have to solve this equation, so I'll distribute my negative sign through, give me x squared plus 7 minus x equals 7. Since we have both x squared and x, I am going to make sure I set the equation equal to 0. That's one of the processes for solving quadratics. So I'm going to be subtracting 7 from both sides, which will give me, oh look, how nice, they cancel out on both sides. So we'll have x squared minus x equal to 0. So we are ready to solve this quadratic. Now I can use either factoring or quadratic formula or other methods. But here, because we don't have that c term, the constant term, factoring is definitely going to be easier. There's a common monomial of x in both terms. So I'm just going to pull out the x, and that will actually be it for factoring. Now that I've factored, I can use zero product property to find the solution. So I'll set x equals 0 and x minus 1 equals 0. So one x value is 0, not done with it though. And the other x value is x equals 1. Now remember, we are solving a system, so our answers are ordered pairs or points, x comma y. So one of our x values is 0, and one of our x values is 1. We still have to go back up and find the y value, and we'll do that by coming back up here to the equation I boxed and replacing x with the two x values. So I'll start by replacing it with x with 0, so -7 plus 0. -7 plus 0 is just -7. So my first y value is -7. My second y value, I'll replace x with 1 this time. So y will equal -7 plus 1. I don't really need parentheses there. So -7 plus 1 is -6, which means -6 is my second y value. And these are my two ordered pairs for the answers. So in this example, we're going to be solving the system equations by graphing, and we're going to be doing this using Desmos. Graphing methods for solving systems aren't the most effective if you're trying to graph it by hand, because if you're like me, your lines are not straight. So we're going to be using Desmos here to solve it, and if you are solving by graphing, either being provided a graph or using a graph or creating a graph for yourself using a calculator is the most effective way. Okay, so I've pulled up a Desmos window, and simply to solve an equation by graphing, you simply just graph each equation. So we have y equals -1/3 times x plus 3. So there is my first equation. My second equation here is y equals -x squared minus 6x minus 5. So there it is. And now we just have to find where the two equations intersect each other. So we can see it right there. Just zooming in to make it a little easier. So these are not pretty answers. Ah, cool. That's new. That's a new feature since I've last done this. But those are the two answers. Negative 3/4 or negative 3 comma 4 is one answer, just looking at the graph, and the other one is negative 2.6 repeated. So comma 3.8 repeated, it looks like. That last digit just rounding, which that second one as fractions instead would be negative 8 out of 3 and 35 out of 9. Okay, in this example, we're going to be solving the system. So in order to do that, we're going to still be using substitution. So I'm going to take my first equation here and solve it for one of the variables. Since my first equation is the linear one, I'm going to prefer to choose that one over it. Before I decide which variable to solve for, because either one is essentially the same difficulty in this equation. So before I choose it, I'm going to look at my second equation. If I look at my second equation here, we can see that x has an exponent on it. So that means if we solve this equation for x, that means we'll have to square it, which is a lot more work in the long run. So I'm going to choose to solve for y because it doesn't have an exponent, and it will make it easier in the long run here. Since I want to get y by itself, I'm going to subtract x from both sides and have y equals 5 minus x. That is not an x. There we go. Okay. So next, now that I have one of the equations with a variable by itself, I'll move into the other equation, replacing y with 5 minus x. The parentheses here aren't really necessary. Plus 1 equals 3x squared plus 2x. So we can ignore the parentheses here on the left and combine our like terms. 5 and 1 make 6 minus x coming down equals 3x squared plus 2x. Now since it's still a quadratic, we still have the x squared. I'm going to start moving things to one side. I like my x squared to be positive, so I'm going to choose to move everything to the right side. And I'll subtract 6 to do that, and I will add x to do that. Just lining up my like terms there. So 0 equals 3x squared plus 3x, combining like terms, minus 6. Now I can try to solve this in a couple of different ways. I'm going to try factoring first because that's the method I prefer. But you could also do quadratic form that work in playing the square. I see that there's a common monomial of 3 that goes into all the terms, so I'm going to factor that out. Give me x squared plus x minus 2. I'll continue to try to factor here. So if I multiply my first and last, we have negative 2x squared. The combination of factors that I need to multiply or to add to be the middle term is going to be negative 1 and positive 2. Since there is no coefficient with x squared, the shortcut here will work. So my factors will be the 3, x minus 1, and x plus 2. We still haven't done the solving part, so it's still equal to 0. So we'll set each of the factors equal to 0 because of the zero product property, and then solve each of those. So the first factor doesn't actually give us an answer, but we'll add 1, give me x equals 1, and subtract 2, give me x equals negative 2. Remember that this is a system, so we're not quite done. We did find our two x values, but we still need the y values that go with it. So we have the x values for the order pairs. To find the y values, I'm just going to go back up to earlier and plug in my 2x value. So I'm going to start by plugging in the 1. So y will equal 5 minus our 1. And 5 minus 1 is 4. So the y value with 1 is 4. Then I'll go back up and plug in my second x value, which is negative 2. So we have y equals 5 minus negative 2. The double negative will make a plus 2. So 5 plus 2 is 7. So the y value with the negative 2 is 7. So in this example, we're going to be solving the equation by substitution, or solving the system by substitution. Now this one's going to take a little bit different of approach. Normally we say the first step for solving a system by substitution is to make sure one of the variables are by themselves. However, that doesn't really matter as much as you think. What matters is that we see what's by itself, or what's isolated, in both equations. So for example, if I have 2x plus 7 equals 5y, and in the second equation I have 5y plus 2z equals 18, since 5y is isolated in that first equation, then in the second equation I can remove 5y and replace it with the other side. What matters isn't necessarily that it's completely isolated, it's that whatever you're going to be replacing in one equation is by itself in the other. So in this case, in this particular example, we're not actually going to isolate one of the variables because a lot of our variables are squareds. Instead, we're going to take the second equation, since y squared is already more or less by itself. Instead of trying to get y by itself, we're going to leave y squared as is. And then when we go into the second equation here, x squared plus y squared equals 25. So instead of just replacing y, because I don't have y by itself, I have y squared by itself, I'm going to replace y squared. So if I replace y squared, we will have x squared plus, well, according to the second equation, y squared is equal to x plus 5. Since there's a plus sign in front of the y squared, I don't really need parentheses around it, equals 25. This makes it a lot simpler than trying to deal with a lot of other exponent things that happen. From here, we'll continue to try to solve it. It's currently a quadratic, so I'm going to move everything to one side by subtracting 25, which will give me x squared plus x minus 20 equals 0. I'm going to go ahead and factor, so multiplying my first and last, we'll have negative 20x squared. Combination I'm going to need is a positive 5 and a negative 4. Since there is no leading coefficient, or it's 1, our factors will be x minus 4 and x plus 5. Able to take that shortcut because there's no leading coefficient, or the leading coefficient is 1. From here, we'll continue to solve. So since we have it factored, we'll set each factor equal to 0 from the zero product property, and then solve each of those equations, adding 4, giving me x equals 4, and subtracting 5, giving me x equals negative 5. Now, here's where it gets a little bit different than before. We have our two x values. We still need the y values that go with it. So we'll go back to the original equation that we had boxed, the y squared equals x plus 5, and we'll replace x with 4 to start with. So we're going to have y squared equals 4 plus 5, replacing it with the 4 first. 4 plus 5 is 9, so we're going to have y squared equals 9. But y is not by itself, so we haven't actually found the y value yet. If we have y squared equal to 9, that means y is equal to plus or minus the square root of 9. In other words, y is equal to plus or minus 3. We actually have two answers for the y value with 4. So that means we have 4 comma positive 3 and 4 comma negative 3. We're not done though. We still have another x value to go back and do. Our second x value is negative 5, so I'm going to go back and plug in negative 5. So y squared is equal to negative 5 plus 5, replacing our x with our negative 5. Negative 5 plus 5 is 0, so we have y squared equals 0. And if y squared equals 0, then y equals plus or minus the square root of 0, which is 0. So y is equal to plus or minus 0, but really plus and minus 0 is still just 0. So our only answer from that second x value is negative 5 comma 0. So in this particular case, we have a total of 3 different order pairs. And if we were to graph the equation would look something like this, where we have a circle and then a quadratic parabola. I believe this one's going to be on its side in this direction, where it's like this, and the 3 graphs are intersecting in 3 different points. Remember, intersections on graphs are the solutions. So that's why we're ending up with 3 solutions. That first graph is the graph of a circle, and the second one is the graph of a quadratic. Since y is being squared, that quadratic is on its side. Okay, in this example, I'm going to be using it to explain elimination method, what's actually happening there. Oftentimes it's glanced over with and just kind of shown as specific steps in Algebra 1. But I want to take a second and talk about why it is the way it is before we move on to doing it with quadratics. So elimination method, the way it works is simply the way when we're solving a normal equation, the way it works here. We add 5 to both sides of this equation. We can add 5 to both sides because it's changing both sides in the exact same way. It preserves the equality. Well, when it comes to elimination, in a system of equations problems, we are assuming that this equation is a true fact for this situation, and this equation, the second one, is a true fact as well. We're just trying to find the specific x and y values that makes it true. So since we know that those are true facts, that means this is equal to this in the given situation. So if I look back at our little side project here, whenever we do this, I could have said, instead of adding 5 to both sides, I could have added 2 plus 3 to both sides on the left side and added 5 on the right side. It's still the same result. 2 plus 3 is equivalent to, I didn't actually need that first plus, but 2 plus 3 is equivalent to 5, so I'm still adding 5 to both sides, just in a different format. Well, that's what's happening with elimination method. The first thing we did for elimination method is we made sure to have the variables with the same coefficients with different signs. So for this first equation, we would want to multiply it by 3 so that both of the y's here would have a coefficient of 6, just with one positive, one negative. So it would give me 12x minus 6y equals 72. So now, since it was a true fact earlier given the situation, that means I know that 72 and 12x minus 6y are the same. So when I actually apply elimination, essentially what I'm doing is I'm adding 72 to both sides of this second equation. Okay? Now, when I add 72 to the right side, it's pretty simple because there's a number on the right side giving me 85. On the left side, when I add 72, just adding 72 as is, that's not very helpful. And in fact, it doesn't get rid of any of the variables. So we want to use 72 in a different way. We don't want to add 72. We want to add what's equivalent to 72, which according to our equation is 12 minus 6y. So instead, we are going to add not 72 to the left, but the equivalent expression, 12 minus 6y. So it ends up being 5x plus 6y plus 12x, I forgot my x, plus 12x minus 6y. And that's why the y's are actually canceling out when we're doing elimination method. That's why we have to have the same coefficient when we do it, because if we do it before we have the same coefficient, they won't actually cancel out when we add them, and we don't get anywhere. But this also means that we don't have to have it in both in standard form in order to actually do this. For example, I could have, so I'm just going to take the modified versions here. I could have negative 6y equals 72 minus 12x. And as my second equation, I could have 5x plus 6y equals 13, which was the original second equation. And since I want the 6y's to cancel out, I want to make sure that I add the 6y's in a way that they will cancel out. So since they are different signs, I will add them to the same side, so plus negative 6y. On the other side, though, I will use the other expression because I don't want to add the negative 6y to both sides, because that won't get rid of the y. Instead, we add the 72 minus 12x to both sides, or to the right side. So we'll cancel out the y's this way, and 5x equals 85 minus 12x. You end up with the same result. So elimination method, it doesn't have to be in standard form to work. It's just convenient if it is in standard form. It's just about adding an equivalent fact or an equivalent expression to both sides of the second equation. And the equivalent expression comes from that first equation. So that's what elimination method is actually all about. Just adding the same number written differently to both sides of the equation so that you get one of the variables to cancel out. Okay, so I'm going to solve this system of equations with elimination method. Now, typically, elimination method you have to have in standard form, but we don't really need that here. What we're going to make sure we have, like normal, is that we have the same variable, just with different signs. So since the first equation has both x squared and x, while the second one only has x, we won't be able to eliminate the x's. Instead, we're going to eliminate the y's, so we want one of the y's to have a different sign. So I'm going to multiply the second one by negative 1. Second equation times negative 1. That will change into negative 1y, or negative y, equals negative x minus 5. My first equation I'm not going to change, so we're just going to leave it as is. I'll just bring it down. So we're going to have the y equals 2x squared plus 5x minus 1. So I'm going to go ahead and just rewrite that first one slightly so that my my like terms line up. So it was negative x, or negative 1x, minus 5. So there we go. The blue equation here doesn't have an x squared term, so I wanted things to line up. Now that things line up, I will just go ahead and add the two equations, add the two sides. Negative y plus positive y are going to cancel out, give me 0. We have no x squares in the first equation, plus the 2x squares in the second, so we have 2x squared. We have negative x plus 5x is positive 4x. And we have negative 5 plus negative 1 is negative 6. Now this is a quadratic equation already set equal to 0, so we can either do factoring, quadratic formula, or completing the square. I'm just going to try to factor. 2 is a common monomial that goes into all the terms. Give me x squared plus 2x minus 3. If we multiply first and last, we have negative 3x squared. The combination of factors that add up to be the middle term are negative 1 and positive 3. So my factors, because there is no leading coefficient, are x minus 1 and x plus 3. Zero product property says we set each factor equal to 0, so 2 equals 0, x minus 1 equals 0, and x plus 3 equals 0. 2 equals 0 doesn't actually give us a solution. Second one, we would have x equals 1, and the third one, we have x equals negative 3. We're not quite done, though. We do still have to find the y values for each. I think the best way to do it this time will be to take the original second equation, the y equals x plus 5, and plug our two x values in. So if I plug my first x value 1 in, so y equals 1 plus 5, 1 plus 5 is 6, gives me the first order pair 1, 6. And if I plug my second x value in, which is negative 3, y equals negative 3 plus 5, negative 3 plus 5 is 2, so negative 3, 2. So there's my two solutions. Okay, so we're going to be solving this system, which is composed of a reciprocal function and a linear function. So we're going to be using substitution to do this. So in the second equation, we already have y by itself, so we're going to take advantage of that. And then we'll just replace y in the first equation with what it tells us y is. So the second equation tells us y is negative 2 over 3x plus 6. So we'll have x times negative 2 over 3x plus 6 equal to 12. We need to simplify the expression on the left. I'll have to distribute the x through, give me negative 2x squared plus 6x equals 12. I forgot the 2 over 3. There we go. I do want to get rid of the fraction. This way I can factor a little easier. So I'm just going to simply, since the denominator is 3, I'm going to simply multiply everything by 3. Multiply both sides here by 3, which will allow us to cancel out the denominator of that fraction. So that will give us negative 2x squared. The denominator cancels out with the 3. 6 times 3 is 18x. And then on the right side, we have 12 times 3, which is 12 times 3 is 36. Now this is a quadratic, so I want to move everything to one side. So I'm going to subtract 36 from both sides to get negative 2x squared plus 18x minus 36 equals 0. I can try quadratic formula or factoring or completing the square, but my preference is to try factoring first, so that's what I'm going to try to do. There's a common monomial in all three terms. Negative 2 goes into all three terms. Remember, if the first term is negative, pull out that negative. That's going to give me x squared minus 9x, dividing each term by negative 2, plus 18. I'll continue factoring, multiplying my first and last. The combination I need to multiply to be 18 and add to be negative 9. It's going to be negative 3 and negative 6. Since the leading coefficient is 1, or there's no leading coefficient there, we can use the shortcut to jump straight to the factors of x minus 3 and x minus 9, or x minus 6. Now, zero product property will set each factor equal to 0. So x minus 3 equals 0 and x minus 6 equals 0. The first factor, which is just the negative 2, doesn't actually give us a solution. But the other ones, the second one will give us x equals 3, and the third one will give us x equals 6. Remember that this is a system, so our answer should be order pairs x and y. So we are going to solve one of the equation, or use our x values in one of the equations to solve for the y value. I think I'm going to use the first equation just because there's less there. So I'm going to write it out off to the side here, xy equals 12. I'm going to replace x with my first x value. So 3 is my first x value, so 3 times y equals 12. If I divide both sides by 3, I'm going to get that y is 4. So my first order pair is 3, 4. My second x value is 6. So xy equals 12. I'm going to plug in my second x value of 6. So 6 times y equals 12. If I divide both sides by 6, I get that y is equal to 2. So my second order pair will be x of 6, and 2 is the y value. And there we go. Okay, in this example, we're going to be solving a system of equations. This is an example of a system that you can't, at least to my knowledge, use the elimination method to solve because the two separate equations don't have the same exponents. So what we're going to have to do to solve this one is we're going to have to get one of the equations to have a variable by itself and plug it into the other. It's not the prettiest thing. So I'm going to start with the second equation, and I'm going to get y by itself because it looks to be the easiest here since it doesn't have a coefficient. So 3x plus y equals 1, and to get y by itself, I will subtract 3x from both sides. So y will equal 1 minus 3x. There we go. Now that I have that, I'm going to go to my other equation. Unfortunately, there's no nice way about it for this one. So my other equation is 4x squared plus y squared equals 9. And because y is squared in this equation, we're going to have a little bit more work cut out for us. So we'll have 4x squared plus y is going to be replaced by 1 minus 3x. And we have this is being squared equals 9. So unfortunately, we're going to have to simplify this out first. So there is a property to shortcut it, but if you don't remember the property, remember that you should write it out twice and distribute things out. So 1 times 1 is 1. 1 times negative 3 is negative 3x. Negative 3x times 1 is negative 3x. Negative 3x times negative 3x is positive 9x squared. I'm going to bring everything else down. And then just combine like terms here. So we have 4x squared and 9x squared. That makes 13x squared. We got negative 3x and negative 3x, which makes negative 6x. And we got the 1 coming down. And so is our equals 9. Now this is still a quadratic, so we need to move everything to one side. So I will subtract 9 from both sides, giving me 13x squared minus 6x minus 8 equal to the 0. So now I need to choose a way to solve this quadratic. I'm going to try factoring first. I don't know if it's going to work. There is no common monomial, so I'm going to multiply my first and last term. If I do that, I get 104, negative 104. We'll have negative 104x squared. The combination of factors that I'm going to need, this is going to be a little bit more guessing and checking. Unfortunately, there is not a combination that actually does this. So for this particular example, I'm going to have to use quadratic formula instead. So we'll have negative b, which in this case is going to be negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a times c, which is negative 8, all over 2 times a, which is 13. Okay, so that's going to lead us to, if we simplify that, we'll have double negative, which will make a positive 6, plus or minus square root of. If we type the stuff underneath the radical into a calculator, we have 452 over 2 times 3, which is 26. Going through to continue, we have to try to break down this radical, which is really only 4 times 113. So overall, we'll have x simplifying to be 6 plus or minus square root of 4 is 2, square roots of 113 over 26, which can be reduced to by a factor of 2. So dividing each number by 2 there, we'll have 3 plus or minus square root of 111 or 113 over 13 as exact answer. Whew. So those are the two x values. We still need the y values that go with it. So we're going to go and use this linear factor. Not going to be the prettiest thing in the world, but we'll replace the x with our two separate x values. Remember, one of them being the plus, one of them being the minus. I'll start with the plus one. So if we do that, we'll have y equals 1 minus 3 times 3 plus radical 113 over 13. So I will distribute negative 3 here through. So we'll have 1 plus, on top of the fraction, we'll have negative 9 minus 3 radical 113 over 13. And then we'll change the 1 into something with a common denominator. So it will become 13 over 13 as a common denominator. This way we can write things as a single fraction of being 13 minus 9 minus 3 radical 113 over the common denominator 13. Or in other words, 13 minus 9 is 4. So 4 minus 3 radical 113 over 13. So one of the answers is 3 plus square root of 113 over 13, comma, 4 minus 3 square roots of 113 over 13. That is the first answer. Not pretty, but it just so happens how this one works out. And if we do the same thing for the other one, it's going to be very similar. I think the will be different is the sign, so I'm just going to do some little editing here. The differences will be the sign, so that will start off as a minus. So instead of rewriting the whole thing again, we have a minus there, which when we distribute the negative 3 through, it will make it a plus, which will make it a plus there, which will make it a plus there. So really that's the only difference. So the 3 minus radical 113 over 13, its y value will be 4 plus 3 radical 113 over 13. Not the prettiest answers. It would have been a lot nicer if I turned it into decimal as well.